Dear friends, today we are going to see sigma level calculations in Excel. Before that, we will see what is Six Sigma. It is a statistical measure of variation or defects in a process. Why do we do it? Because it helps to eliminate the root cause of defects or variations and the costs associated with them. A process achieves Six Sigma level if the quality is 3.4 DPMO. DPMO means defects per million opportunities. How do we calculate this DPMO and sigma levels? That's what we are going to see here. For a given sample process data, we can find the mean and standard deviation. Please note sample process data is a continuous data. X variable values will be given. Number of values will be given, which is called sample size. Now, from a given sample process data, that is for the above data, for a given customer, please note when I say given customer, customer requirements, customer specification limits, upper specification limit and lower specification limits. We can find capability indices CP and CPK. We can also find DPMO and short-term and long-term sigma levels. I'll repeat once more. For a given mean and standard deviation, USL and LSL, we can find CP, CPK, DPMO and ZST and ZLT. We can also find for a discrete data, so far we have found out for continuous data. For a discrete data also we can find the DPMO and short-term and long-term sigma levels. The defects or defectives, defective means rejections. Finally, for a given DPMO, the DPMO can come from continuous data or discrete data. We can find the short-term and long-term sigma levels, which I'll explain in the final stages. How do we write this formula in Excel worksheet? That is more important for my lifetime use. I can forget this formula, but anytime in my lifetime, if I substitute the input data, I must get the output in no time. So make your own Excel calculator to find out these parameters in 5 sections. Section 1 is to find out the sample mean and sample standard deviation for a given sample data. That is X bar and capital S. In the second sections, for the same data, for customer specifications, USL and LSL, we can find out the CP and CPK. And in the third section, for the same sample data and customer specifications, we can find out ZLSL, ZUSL, which are to be used in the standard normal distribution curve to find out the p-value, which when multiplied by 1 million will give you DPMO. And then from DPMO, I can find out long-term and short-term sigma levels. That is ZUSL, ZLSL, DPMO. And for discrete data also, we can find out DPMO for defects and defectives. In the case of defects, there are two options, OFE is known or unknown. If OFE is opportunity for error per unit, if it is known, we will use that value. If it is not known, we will take it as 1. For defectives, OFE is redundant, it is not relevant. Now finally, from the DPMO, we can calculate short-term and long-term sigma levels, GLT and ZT. First, we will go to the sample data and use an Excel sheet to find out the mean and standard deviation. Please note, input values are only in gray cells. Under the data column, we can add data. Once I add data, serial number will automatically fit in. This serial number indicates the sample size and mean and standard deviation are calculated here. We will go to an Excel sheet and then see how it is calculated here. Now please see here, for 6 data, mean and standard deviation are calculated here. I will add one more value, 0.5. You can see that 7 is added and mean and standard deviation are revised. Now I'm using 3 formula here. One formula is here. This is going to test this adjacent cell. If there is a value, then it will go and test this previous cell, that is B4. If there is a number, it will add 1 to that number. If there is no number, it will start with 1. That formula is given here. If you can't see it, you can see it here very well. That if C5 is equal to double quote, comma, that is, if there is a value here, that is C5, there is a value here. Then if is number B4, that is, I'm checking this B4 cell, right? If it is a number, then I will add 1 to that. If it is not a number, I'll start fresh with 1. That is what is this cell formula states. Then I will copy this formula to 1000 cells below, so that I can add up to 1000 data and get the mean and standard deviation. Okay, you can copy paste this cell and then copy this formula to over 1000 cells here. Then we will see what is the formula for this here. So it's shown here. I will show it clearly here in this. Average AC5 to C1004. That is in this 1000 cell ranges, C5 to C1004. it will find out which are all the cells which has got numbers, non-empty cells, and I'll find out the average only for those cells. Similarly, here also standard deviation, I'm using STDEV A. A is very important because then only it will calculate the standard deviation for only those cells which has got numbers. Okay, and now we can use any data, any column data, and find out the mean and standard deviation. All you need to do is it should be in a column format. So I have got a W column. I'll see that I'll show you this column there. So 100 data are there. What I will do is, this is data taken from some other Excel file. I'll just put Control Shift down key. Then it is selected. I'll press Control C. Then it is copied. Now I'll go to the home. And then under the data, I'm going to copy all these cells. Please note, very important, I'll have to copy only values, right? Otherwise it will give error. So I have copied. So serial number is automatically filled in. You can go and see here 100 data will be there. See, 100 data are there, right? It will go there. And then mean and standard deviation also are obtained. So with these three cell formula, you can find out the standard deviation and mean for any amount of data. Okay. Then we will go to the capability indices, that is called CP and CPK from the given data, right? You can copy this text values in your Excel sheet as it is, right? It is all very simple. These input values also you can copy as it is from this, or you can put any other value. And this formula cells, I will to tell you. These orange cells with numbers, CP value, I'll give you the formula now. CP is equal to numerator by denominator. Numerator is nothing but the distance of the black arrow line, USL minus LSL. USL is 229, LSL is 224, difference is 5. Denominator is 6 times 1.63, 6 times sigma. Therefore, CP formula can be easily put. And for CPK, it depends upon the position of the process. Here it is shifted to the left because the target is 226.5, whereas the process mean is 226.36, 0.14 lower than this, so it is lower. Therefore, here it is process mean minus LSL divided by 3 sigma is the CPK value. If it is shifted to the right, accordingly, USL minus process mean divided by 3 sigma will be the CPK value. I'll show the formula here. Please note here, CPK is equal to mean minus LSL by 3 sigma or USL minus mean by 3 sigma. Both are positive values. So whichever is lower, I have to take it here. Now I will go to this Excel and then see how we can do it. Is here. See the formula here. CP is equal to C2 minus C3 divided by 6 times 6, C5. C2 is USL, C3 is mean, C5 is sigma value. And similarly here, CPK is the minimum of the two values. Minimum of C2 minus C4 by 3 sigma, C5 is sigma, C4 is mean, C2 is USL. Or C4 minus C3 by 3 sigma, C5 is sigma value, C3 is LSL, C4 is mean. Right? So the minimum of these two values will be, I have copied it here. Please note, left hand side of the formula should not be copied. Only the right hand side of the equation should be copied and pasted here in this C7 cell. Okay? Then DPMO calculations, I'll show it here. Please note what it does is, first of all, it checks the USL and LSL are numbers. Right? C3 is not equal to blank and C2 is not equal to blank. And then it is finding out normal distribution for the C4 and C5 is for this mean and standard deviation. True means left hand side area for C3. C3 is LSL. LSL is on the left hand side. Yeah, therefore left hand side area is true means left hand side area. I take it directly. And for this value is an USL, I have to take the right hand side area. Therefore, but since I have used true, it is going to give you the left hand side area. So I am subtracting from to get that right hand side area. 1 minus the right hand side area, left hand side area. So that P value is obtained for both the left hand side as well as for right hand side. These two are added and multiplied by 1 million because P is nothing but fraction defectives per opportunity. So per million means I have to multiply by 1 million. So we will go to the other slide where we are going to give the details of this DPMO calculations. I have explained in a short way. In detail way, I am going to explain here. Please see that Z LSL x minus x bar by standard deviation. What is x? X is nothing but LSL. It is shown here 224. minus 226.36 divided by 1.63. So you are getting it. And what is USL? Is Z for USL? X minus X bar by sigma. X is 229 minus 226.36 divided by 1.63. So I can use this formula here. And I have to find out the DPMO. DPMO is nothing but ZLSL is here. Left hand side area is P value multiplied by 1 million is DPMO. Similarly, I have to find out the right hand side area for this. Since it is a positive value and right hand side area I want, and the formula gives only left hand side area, I have to subtract from 1 and then it will give you this P value here. Multiplied by 1 million will give you DPMO. So total DPMO can be calculated by adding the two. Once total DPMO is calculated, I can calculate the sigma level, long term and short term. Now we will go to this Excel sheet. Go to this Excel sheet. This is a value here, the USL. I'll just give you the formula here so that you'll be able to see it clearly. DPMO is equal to 1 million to P value. Then for USL, Z value is how it is calculated. You can check up. For LSL, how it is calculated, you can check up. B5 minus B3 by B4, B6 minus B3 by B4. So B3 is mean, B4 is standard deviation. B5 is nothing but X USL value. B6 is X, nothing but LSL value 224. Okay. Once I get these two values, I'm going to substitute the formula for DPMO. DPMO is nothing but P value into 10 to the power of 6. P value is nothing but defects per opportunity. That is absolute value of B9, that is 1.619. Since I want the right hand side area and the formula gives true means left hand side area only it gives. Therefore, I'm just changing the sign and then finding out. So which is nothing but the area to the right here. This is just an adjustment I'm making in the formula to get the right hand side P value for ZUSL. Similarly, I can find out the Z value for LSL and the P value and multiplied by 1 million, we get DPMO. So this is nothing but minus absolute value means it will become a plus. Then I'm putting minus absolute, therefore it will become minus 1.44. So left hand side area is what is wanted. Therefore, we are using it as it is. Okay, clear? Now we will go to the next session. You can change now here. You can now change these values here. 225. So all these values will change. Yeah. Okay, 226.39. 39 only. Right? So it will be like this, right? 226.36, 226.34, 1.14, 2.64. It comes back, right? Now we will go to the defects and DPMO, right? That is, there are two cases here. For defectives, one case. For defects, there are two options here. OIF is known or OIF is unknown. If it is known, whatever value you put, I'll multiply this with sample size. So I'll get total opportunity for error. And then DPO is nothing but defects divided by total opportunity for error. That is defects per opportunity. Multiplied by million, I'll get defects per million opportunities. Similarly here, 86 is given defectives, 2000 is the sample size. Therefore, DPO is 86 by 2000. Right? DPMO is, I just multiply DPO by 1 million, you'll get it. Apart from that, there are two other values I'm calculating. Yield percentage. Yield is nothing but 2000 minus 86. If 86 are rejected, balance is accepted. So 2000 minus 86 divided by 2000 into 100 is the yield percentage. The balance is 100 minus yield percentage is defective percentage. So we can also calculate the defective percentage in a different way. 86 by 2000 into 100 is the defective percentage. 100 minus defective percentage is yield percentage. So there are different formulae here. Whichever formula is comfortable to you, you can use it. And once DPMO is known, in these cases, you can find out the sigma levels, short term and long term, right? What we will do is we will go to the Excel sheet and then see how it works. Now here, 119 defects are there, 500 sample size. OIF is given as 2, I'll make it as 3. Then you will see that DPMO is 79,333. And you can see that sigma level calculated here, right? And suppose I'm just saying that unknown. Then what it will do is it will take it as 1. So 500 into 1 is 500, OIF. Then DPO is 119 by 500, 0.238. Then it will be 238,000. And sigma levels are calculated accordingly. And in this case, I'm just making it as 70. Then it will change 96.5. I'll make it as 86 again. We will see this 96.5 is changed to 95.7%. And 43,000 is DPMO. You know the formula here. You can see here I have shown the 1 minus K2 by K3, but I have selected the percentage symbol here for number. Therefore, it gives in percentage. Similarly, it is giving 100% minus K4, that is yield percentage. And this is, I can put K2 by K3, 86 by 2000 value here. And multiplied by 1 million, K6 multiplied by 1 million, this is the formula here. And similarly here also, you know that this TOE formula, TOFE formula I have written here. You can go through that. TOFE is equal to if C4 is less than 1 or it is a text. If it is, I put 0, it will take it as 1. Right? It will take it as 1. If you take it as 1, it will take it as 1. If you take it as unknown, it will take it as 1. If you make it as 2, then it will take that value. Right? So it will check whether it is less than 1 or text. And then in that case, it will take it as 1. Otherwise, it will keep that value as it is, C4, and multiplied by the sample size. So this formula is the only formula you have to note down from here. The rest are very easy. This is nothing but defects divided by TOFE. You can see here C2 by C5. And then this is C6 multiplied by 10 to the power of 6. Right? So it is very easy to put in your Excel sheet yourself. Now we will go to the DPMO calculations, final calculations here. Now, once DPMO is known, we can find out sigma levels. How are we going to find out? See here. Please note, if sigma LT is, long-term sigma is plus infinity, what is to the right of it? Then to the right of it is 0. Therefore, 0 defects. That means all the 1 million goods produced are very good goods, right? Very good products. Therefore, ZLT is plus infinity means 0 defects. I can put 0 defects and then find out whether I'm getting this. And then what I will say is I'll just put ZLT is minus infinity. To the right is the entire 1 million defects or products are there to the right. To the right is defects, no? Therefore, all the 1 million goods are defects. Only 0 goods produced. So that is the indication of ZLT is equal to minus infinity and ZLT is equal to plus infinity. Suppose it is in between. Then ZLT is long-term Z value somewhere here. Then to the left is a good value, good items. To the right is defect items. Okay. And then we can see here. The long-term what will happen? See here, ZLT will be shifted to the ZST. The short-term now, the defects will be very less, right? Therefore, I add 1.5 to ZLT and then I get short-term sigma level. So defects are only this much. Clear? Understand? So what we will do is, we will do this in an Excel sheet, right? I'll go to this Excel sheet and then see what all these things are there. See here, all these values are there. I'll put here 1 million. That means all the things are defects. That is, you should get in minus plus infinity, right? 1 million, it is not 1 million, right? Okay, 3, 1, 2, 3, right? Minus infinity. Right? All the 1 million pieces are defective. Though see here, minus infinity. All are to the right, everything is to the right, defects. Suppose I put 0, then it should be plus infinity. This is the plus infinity here. Suppose I put here 3. 3 is, you know, how much I should get? 6 sigma. Sigma ST should be 6. See here, I'm getting 6. ZLT is 4.5, which corresponds to 3 defects per million opportunities. Okay, I put somewhere here 1000, it will have the value. ZLT is 3.1, here 3.1. I add 1.5, it will become 4.6 here. Right? This is what how you find out the sigma levels for a given DPMO. Right? Simple formula, you can copy it here. The formula that I have used, I'll show it to you here. Right? So if C4 is equal to 1 million, that is, this is 1 million, it will be minus infinity. If it is equal to 0, it is plus infinity. Otherwise, it is inverse formula, norms inverse. 1 minus C4 by 1 million. C4 by 1 million is, C4 by 1 million is only P value, right? So since the area to the left is what is considered in the graph, so I'm subtracting from 1 so that left-hand side area is there. Once I know the left-hand side area, this area, I can find out the Z value, right? So either I can give Z value and then find out the left-hand side area, cumulative distribution function, or I have this left-hand side area and find out the Z value using the inverse function. And similarly for ZST, the same formula I'm using it, except that I'm adding 1.5 here. Please note the formula is same with respect to C4, and then 1 minus C4 by 1 million. Here I have added after this plus 1.5 here. Therefore, you can add this value. I think this completes the session. You have almost completed your Excel sheet to find out any parameters at any time in life. You can forget coolly this Excel formula. All that you need is you just give the input values. You will get the sigma values, right? Long-term and short-term values. You can also find out the mean and average, that is standard deviation and sample mean. You can find out for any amount of data from this Excel sheet. I hope you like this. If you like this, please recommend to your friends so that they can also benefit. Thank you very much. I'll stop sharing here.